right, so we were talking about sampling. Now we're going to talk about, so the first half is all about like getting the participants in a study. The second half of the study is going to be about setting up an experiment, okay? So, so usually when we have a random sample, we do an observational study on it. Sometimes we do experiments on random samples, but more likely an experiment is done on a group of volunteers. Okay. There's plenty of reasons why we do experiments on groups of volunteers. So, for example, let's say I am testing a new drug for baldness. You guys with me? Should I be one of the people that participates in a baldness study? No? What about Mr. Wyan?
No. Definitely not Mr. Wyan.
Mr. Belk? Yeah.
We need Amy.
The loudmouth next door? He'd been bald since before I can remember at this point, guys. I actually remember him when he had hair. He used to do this horrendous comb over. It was real bad. It was real bad. Okay.
Do you have a picture of this?
I do not have a... I don't think I have a picture of it. But I am not above going through his classroom to find one. For sure. Definitely not above that. And he's not here today. This would be the perfect day to do it. It was so bad. So bad. He used to not have any facial hair and a comb over. That's pretty... We don't have many male teachers with hair. Hecker, Wapner,
Peters isn't bald,
McCarthy.
Peters isn't bald, but he just changed it.
He's close.
He's like a buzz.
His
He's a
hairline's
buzz.
pretty,
Yeah, and you know why he does the buzz, yeah? He's pretty, his crown's pretty thin at this point, yeah.
It's hard to see his crown. He's so tall.
Tell me about it. Tell me about it. You guys, when I cover his class, it's hilarious because I'll sit in his chair. His chair's so much bigger than mine. Like my feet don't touch the ground when I sit in his chair. So funny. So funny. Okay, so needless to say, a lot of times for experiments, the participants in an experiment are usually volunteers, and the experiment is about something that's important to those volunteers. That's okay. It doesn't influence. There are other things that we get from experiments that we're maybe okay with it not being a random sample because we can conclude some other extra more strong results. Okay. So can you guys remind me what made something an experiment? Testing a variable. I'm going to use a specific word called treatments. We assign treatments. They are ways that we manipulate people. Okay. So, let's say I'm trying a new hair loss drug. I might take my bald guys in the building. So, almost everybody that's a male in the building. Let's say there's Rummer. Ballinger has hairs, doesn't he?
Yeah.
It's just very thin.
Yeah.
Is it? It's thinning out.
I don't know why he doesn't.
Does Johnson's pretty bald.
Yeah, Miss Johnson.
He's pretty bald.
Stork.
Braga.
Grega does have a
Ginner.
Ginner. Oh, I forgot about Guinea. And oh my gosh, you guys, we would have a lot of participants in this study. Yeah. So, and then let's go ahead and say I have 2 different drugs I'm going to try on them. Okay, everybody with me? So half of them are going to rub some sort of weird thing on their scalp and peppermint oil or something, and then the other half rub some other weird thing on their scalp to make the hair grow, right? Like Dr. McGillicuddy's magic tonic from school. You guys give it a... I'm going to shut up now. Anyway, it's because I make a recording. I'm rambling. So in experimental units. And so with experimental unit is just whatever receives the treatment. So it could be people, okay? But it doesn't have to be people, right? If I do an experiment on lab rats, that would be The rats would be the experimental units. If I'm trying to test a new fertilizer, the plants that I put it on would be the experimental units. Okay, so I don't want us to think experiments only happen to subjects of like people. Okay? All right. Treatments are the manipulations we assign. Okay. The explanatory variable is what it's been this whole time we've been talking about it. Okay, that independent variable. I'm going to call it the umbrella over the treatments. Do you guys remember when you guys were my experimental units with the AJ Nate versus Nate AJ thing? Okay. And when we did that, y'all, the treatments were AJ, then Nate first, and then the other group was Nate, then AJ first. You guys get what I'm saying there? AJ and Nate? Yeah. Yeah. Okay. And those were our treatments, but overall, the explanatory variable was the order in which I gave you guys the boy's name. That was the umbrella that covered both the different
Pardon the
orders.
interruption for just a brief announcement. I just want to let you know that the Federal Emergency Management Agency is going to be conducting a nationwide test that's going to be testing infrastructure of their national testing system. This is going to be a test that's going to be sent out to all TVs, radios, and most effectively here, all cell phones. This is going to be at 2:20 p.m. The message is going to read, "This is a test on the National Wireless Emergency Alert System. No action is needed." I just wanted to give you a heads up before everyone's phone started going off that everything is okay and this is just a nationwide test. Thanks for your time and go Bobcats.
You were recording.
Can you put like everyone's phone?
I'm fine with that. I like.
Leave it on, leave it on.
Isn't that the kind of thing though? Like when you hear it on the recording, when you're watching the recording, it would make you laugh a little bit.
Yes.
Yeah. Go Bobcats. Okay. Response variable is the variable of interest. It's okay. So in some respects, the explanatory variable is the variable that we do the changing to. The response variable is the variable we're looking to see a new change in. Does that make sense? We change the one and see if there's a change in the other. And then lastly, we have something called confounding. This, you guys, confounding is bad. And confounding happens when an outside variable makes it look like the treatments are affecting. I'm not going to say the treatments. That makes the explanatory variable is affecting the response variable. We've already talked about some confounding this year. You guys remember the sharks and the ice cream? What was the confounding variable?
The temperature.
The outside temperature, yeah. Like when it's warm outside. Okay, so if you had to explain that confounding, we're going to have an opportunity to do that in a second. Warm weather, when you could describe that confounding, warm weather increases swimming. And increases ice cream sales. So, do you guys notice as I describe what this is? Okay? As I describe what that is, I'm not just saying, oh, one is going up. I'm making sure I'm showing how the warm weather causes both things to change together. Okay, so when we describe confounding, A lot of times what happens is people end up describing confounding by talking about the response variable only. And you really, in order to do it well, you need to link that confounding variable to the explanatory variable and that response variable, okay? So, here's the deal. Yes?
Confounding, like, is it only present when your explanatory variable has no impact on the response variable, or could it just boost the impact of it? Like, is it present?
The bigger idea for confounding is that you don't know which variable's doing which work. In an experiment, we have experimental use. Okay. Now here's the deal. Experiments, because we have treatments, we end up with treatment groups. Like we're comparing two groups to each other. Okay? And here's the deal. If the only difference between two groups is the treatments, and we see a big difference at the end of the experiment, the treatments cause that difference. And everything else we're talking about is, so I want you guys to think about my hands as treatments, or as treatment groups, okay? If I have two groups of people and they start out like this, they get the treatments, and they're still like this, or even if they're like this, and they've changed, okay? Do we know that the treatments did anything to cause that change?
No.
No, if it's already high, it's already high, yeah? If this hand's already higher, then the treatment, we don't know what effect the treatment had. So what if my hands start out like this? And then the treatments happen. So they're starting out the same beforehand. They get the treatments, and then they are different. Now I am comfortable concluding cause and effect. Okay? In a well-designed experiment, which is our whole goal today, is to talk about well-designed experiments. Okay? In a well-designed experiment, we are allowed to conclude cause and effect. So we might be just happy to conclude cause and effect about a group of volunteers. Because that's still a pretty powerful conclusion. Okay? Everybody good? All right. So here's just a quick, I'm going to let you guys read this real quick. I'm going to take a sip of my water.
It's close.
I know. Oh, I know. It's 2:16. In 4 minutes, it's going to be crazy. It's going to be mayhem in here. You guys, observational study or experiment? Observational study, I agree. And why?
Because they're not actually they're not implementing a treatment. They're just like seeing what happens in normal conditions.
Yeah, what would the dinner with family is not randomly assigned. It either occurs or it doesn't with the people, okay? And what is the explanatory variable here?
Or how often do you use the variables?
Eating with the family. Okay, cool. And the response? Cool. All right, now, why can't we conclude cause and effect here?
Because we don't. No, because it's not an experiment.
Okay, so the thought process you would start with is because it's not an experiment. Okay. What you wouldn't want you would not want to put that as an answer, though. You would want to be a little bit more descriptive. Okay? So, I might say, and I love to use examples to be descriptive, so does the College Board, okay? Maybe there's a different variable.
Did you record the video?
No, I got, the very beginning of it got recorded, and then I paused the recording. Maybe there's. Let's hope Kenny wasn't in the middle of his backswing right when that came on, right? That would be bad. Maybe there's a different variable that's tied to both grades and eating with the family.
I'm not either of those things.
Okay, guys, can you describe one? What is a possible confounding variable here? Strict parents, sure.
If they have parents.
Well, but like, this is very much worded to be about family, not parents. Yeah.
A lot of extracurriculars that they're like busy with.
Okay. Cooper's getting close, for sure. I think that's a reasonable, the word strict, though, I think has this like connotation that I'm gonna ever so slightly change, okay? So I want you guys to think back to the last time you sat down with your families. This happens with me still. What's the first thing they ask?
How was your day?
How was your day? How's school going? People who sit down with their families more frequently have more frequent check-ins with their family. Do you get what I'm saying? It's not the act of eating dinner with your family. It's the communication and the check-ins. Okay? So if I were to to describe that confounding well, you would need to say, all right, the confounding variable is checking in with parents or with families. That leads to increased grades. And I think that's a reasonable thing. Parents who are also on you about getting your homework done and have you studied? What tests do you have this week? Blah. You guys get what I'm saying? Okay? And happens during dinner time. Could happen during dinner time. And certainly, I can't remember a single meal with my family in which my mom didn't ask me how school was going. To this day, I call her, "How was school today?"
Have you never not been in school?
Nah.
Is that, did you ever think, like, you'd always be in school? Like, I feel like everybody, like, can't wait to get out of school.
I always envisioned myself as a teacher.
So right after college, you just become a sub.
You, like, came in. And
No, I had a teaching job right away. I taught.
Studying East Coast, like, right?
That wasn't allowed 20 years ago. I student taught, but I also had to take my courses to finish and graduate on time. All right, everybody good? All right, so one of the things I want to make sure I emphasize here is you notice that this is describing the effect on the response variable, but it also is the explanatory. And I want to make sure I'm emphasizing that when you describe confounding, you show two arrows, one going to the response variable, one going to the explanatory variable.
In this case, would you, like, if you're trying to be thorough, would you actually conduct a test and you would make it, like, your explanatory variable would be the number of times you check in with your parents and then, like...
So this study is trying to decide, does eating work? Does eating with your family increase student achievement? And if that were the case, you would assign kids to eating with their families or eating their dinner with their families or eating their dinner elsewhere. Okay? And you would assign it over a decent amount of time. So for the next 3 weeks, you're going to eat dinner elsewhere, but these guys are going to eat dinner with their family and then compare the grades. That would then do it. And I think what you would find, if that is the only thing you change, it probably wouldn't influence grades that much because you would still be checking in with your family, just not eating with them. Does that make sense? Okay, everybody good? Let's take 5. Those of you at home, please pause the Miss Meister Made YouTube video and look at the other link that I emailed you and watch that video quickly. Can you guys what was the general idea of that video?
Could you tell, or could somebody tell if tea or milk was poured?
Which one was poured first, right? Could somebody identify the difference? And was that an experiment or an observational study?
It was an experiment because they had a say in what they were given.
Okay, and what were the treatments?
Tea first or milk first?
Whichever, the different, what was it, the way each cup was poured? Okay, all right. What else though? Like, they didn't just pour the tea. There's some other things they did, yeah?
They didn't let her see which one was poured first.
Okay, so she didn't know which one she had at any given time. What else?
Probably how she give them in a random order.
He did kind of talk about what order should we give it in, so hopefully she got the tea in a random order. What else?
It's the way she gave her responses, maybe?
It was milk versus tea, whichever came first, yeah. How about this? Can she taste the difference?
I think so.
Yeah.
Tell me what's convincing you.
She got all of them correct.
She got all of them correct? Cool. Would you guys have been convinced if she got 2 out of 2 right?
Less
I would
convincing.
have.
Less
It's
convincing.
not as strong.
I would say 2 out of 2 is unconvincing, you guys. 2 out of 2 would be unconvincing. What about 3 out of 3?
Yeah.
There's definitely a draw of 5.
4 out of 4?
Yeah.
5.
5 is what would convince you?
5 for 5.
How many would she need to get right? Like, where you're finally like, yeah, there's no way that she's not doing this. There's no way that this is just luck. You guys get what I'm saying? There is a point, right? Because if she got 100 out of 100 right, would you guys be convinced?
Yeah.
So would I. That's pretty crazy, right? But if she got 5 out of 5 right, could she do that by just guessing?
Yes.
Could she just be getting lucky?
Yes.
Right? What if it was like 10 out of 10 maybe is more convincing, right? Are you with me that the number of trials increases our convincing?
I think the number would go down if she didn't know if there was an even out or each word. So if she
That's an important thing. Did she know that it was 4 and 4?
because it was like 5 and 3, and she got 4 right, and just guessed the other ones were 4.
Yeah. Yeah, for sure.
I mean, I feel like if she wasn't told, she would just assume that it's poured.
Do you think so?
Yeah.
I'm gonna feel if I.
I mean, I would.
Okay.
It depends on how much she orders normally, I guess. Like what was normal before.
Certainly, a larger sample size would be much harder to keep track of what she's already said to know if she's done 4 and 4 versus 10 and 10, right? For sure. Okay. There were some other things they said that I'm not sure came across, so I want to make sure we talk about that. They said that they did the milk and the tea in the same proportion. So, why is that important?
If there was more of one, that flavor might.
It might be the flavor instead of, yeah. So, with that, are you guys cool with saying that we hope that they took like a little teaspoon and mixed the tea with the teaspoon? So that, like, there wouldn't be the same coloring. Hopefully they used the same kind of tea for each cup, right? There's one other huge thing that I think that I would hope that they were paying it. Two things that
Same classes.
the cups needed to be the same, and hopefully everything was served at the same temperature. You guys with me? Okay. And all these things we're talking about is the first element of good experimental design. Okay. So every good experiment has 3 elements: control, random, and replication. Okay. So
I'm a genius.
you guys, the controls is the TV is technically on. The iPad is just not connected to it.
On the TV.
Yeah. Okay. You guys, control. When I say control, what we want to do is eliminate as many differences between our treatment groups as possible. So, for example, we want everything in the same cups so that the type of cup is not a difference between the treatment groups. Does that make sense? The same temperature. And so what's our goal in that is it's saying let's look at those teacups and let's make them as the same as I possibly can before I do the treatments. Do you guys get what I'm saying? Can I account for every single possible variable?
No, because if it's human stuff too, then you have to.
Not just human stuff, like we're pretty dumb. Like human beings aren't great at recognizing the outside forces that they can't see. You guys know what I'm saying? Like, so what we do is, and this came through in the order, but it depends on how we do it. The way we assign treatments needs to be random. And what that does is it takes all those confounding variables that you can't think of, and it makes sure all the different treatment groups have those confounding variables in them. So those confounding variables are no longer a difference between the treatment groups, but in fact a similarity between those treatment groups. Everybody good? And the goal of these first 2 is essentially we're trying to make sure the only difference between groups is the treatments themselves. And so earlier, I was like, can we conclude cause and effect? And Blake said no, because it wasn't an experiment. The real answer that the College Board would be looking for would start with that, okay? And then say, without having an experiment with randomly assigned treatments, we don't know that there weren't already differences between the treatment groups. Whereas the random assignment, the controlling for variables, allows us to assume that there's no difference between the treatment groups before the treatments. Okay? So just saying not an experiment would not have been enough, but you could add in this idea of making the treatment groups have only one difference, the treatments themselves. Okay? All right. Lastly, replication. We kind of hinted at replication already. Replication is that when we see that the treatment groups are large enough that the differences we see could not just be chance. Okay. Let's talk about a few other words with experimental design. Oh, wait, I want to hit on this a little bit more. You guys, I want to make sure we understand when I say treatment groups are large enough that differences can't occur by chance. That is not saying that you need a large sample. I want to make sure we understand this because, one, how large is large enough for a sample is a messy, messy question. Very, very, very messy question. So rarely are you going to say, no, the sample size was too small for me to make a conclusion. Okay? Anything regarding sample size, I don't want you thinking about sample size until unit 5 or 6. Okay? It's more about the how it's gathered versus the size of what was gathered. Okay? We care more about the logistics of the setup of a sample or setup of an experiment versus the size of that sample. Okay? All right. Now, how many of you guys have heard these words before? Control group, placebo effect, single blind, double blind. Have you guys heard of all of them?
Yes.
Okay, so you guys tell me, what do they mean?
A control group is that you do nothing to.
A group with no treatment. Okay, do we need a control group?
Yeah.
Nope. No. We need comparison groups. But we don't need a control group. And there are times where a control group actually isn't really feasible. Just like there are times you can't do a single blind or a double blind study because of what the treatment is, you're going to know which treatment you got. Okay? All right. What's the placebo?
A group that thinks they got a treatment but didn't.
It's like if two groups are taking a pill, one is nothing, and one actually is supposed to fix it.
Sure. Like we just use regular shampoo on Mr. Belk's head. That's the placebo. And then we use the actual hair treatment on Mr. Richard's head. Right? That would be a placebo. Okay. And so the placebo effect is that there are responses to treatments regardless of the treatments themselves. And so we give those dummy treatments so that even when we see that effect, we have another group to compare to see just was the act of getting a treatment what caused that impact or not. Okay. And then single blind and double blind, what do those mean?
Single blind, the subjects have no idea what's happening.
I'm going to say it a little bit differently. I'm just going to say one side of the experiment doesn't know the treatment. And then double blind is both sides don't know the treatment. And this is for similar reasons as the placebo effect, right? It's if you know that you're getting one treatment versus the other, you might have your own subconscious or unconscious biases towards one treatment or another. Great. How are we feeling so far? You guys, let's call it a day.